Hardware. This includes cables, connectors, RAM, storage devices, RAID, motherboards, CPUs, and power supplies. These diagrams will help you visualize form factors, pin layouts, connector types, and performance differences, all of which appear frequently on the exam. Part 3. Hardware. Domain 3.0. 3.1 Cables and connectors. Physical layer mediums dictate the performance limits of network and device links. Twisted pair copper standards. Cat5 is rated for speeds up to 100 megabits per second at maximum distances of 100 meters. Cat5e is rated for speeds up to 1 gigabit per second at maximum distances of 100 meters. Cat6 is rated for speeds up to 10 gigabits per second at reduced distances up to 55 meters. Supports 1 gigabit per second up to 100 meters. Cat6a, augmented, is rated for full 10 gigabit per second speeds at maximum distances of 100 meters. Plenum-rated cables. Wrapped in fire-retardant material, fluorinated ethylene propylene or Teflon, that produces minimal smoke and zero toxic halogen gases when burned. Legally mandatory for air handling spaces. STP versus UTP. Shielded twisted pair, STP, uses internal conductive foils to block electromagnetic interference, EMI, but requires structural grounding. Unshielded twisted pair, UTP, is standard cabling susceptible to ambient EMI fields. Fiber optic infrastructure. Single-mode fiber features a narrow glass core that uses laser diodes to carry data over long distances measured in kilometers. Multi-mode fiber features a wide glass core that uses LED drivers for short, localized building runs spanning hundreds of meters. Standard fiber connector shapes include ST, straight tip, bayonet latch, SC, subscriber connector, square snap-in, and LC, Lucent connector, small form factor snap-in. Video and storage formats. High-definition multimedia interface, HDMI, carries digital video and multi-channel audio on an active 19-pin layout. DisplayPort is an open digital standard utilizing packetized data streams. DVI options include DVD, digital signals only, DVA, analog only, and DVI, integrated analog/digital. VGA uses an analog DB15 configuration. Internal storage relies on SATA connections, which use a 7-pin data line and a 15-pin power connection. SATA revision 3.0 caps out at 6 gigabits per second. 3.2 RAM, random access memory. RAM provides volatile workspace memory for active CPU threads and operations. Physical architectures. Desktops use full-size dual inline memory modules, DIMMs. Laptops utilize small outline SODIMMs. Generations and pins. DDR3 uses 240 pins. DDR4 uses 288 pins, operating at lower voltages, 1.2V, and higher clock ranges. DDR5 uses 288 pins with modified indexing channels. DDR5 relocates power management tasks from a motherboard to an onboard power management integrated circuit, PMIC. Bus topologies and validation. Installing identical memory kits across color-coded motherboard slots unlocks multi-channel architectures, dual or quad-channel, to expand overall bandwidth. ECC, error-correcting code. RAM detects and fixes single-bit memory corruptions in real time. ECC requires matching motherboard chipset and processor support, making it standard in enterprise servers but absent in consumer hardware. 3.3 Storage devices. Non-volatile storage architectures maintain data integrity after system shutdowns. Hard disk drives, HDDs utilize spinning magnetic platters and mechanical read/write actuator heads. Standard consumer rotational velocities operate at 5,400 revolutions per minute or 7,200 revolutions per minute. They provide high storage capacity at the cost of high mechanical latency. Solid-state drives, SSDs built on non-volatile NAND flash memory arrays with zero moving parts. 2.5-inch SATA SSDs are limited by SATA 3 interface bounds, 600 MB/s. M.2 NVMe SSDs access the PCIe bus directly, delivering transfer speeds over 3,500 megabytes per second. Optical media capacities. Compact discs, CD, store up to 700 megabytes. Digital versatile discs, DVD, store 4.7 gigabytes on a single layer and 8.5 gigabytes on a dual layer disc. Blu-ray discs, BD, store 25 gigabytes on a single layer and 50 gigabytes on a dual layer disc. RAID arrays. RAID 0, striping, distributes blocks across 2 or more drives to optimize performance but provides zero fault tolerance. RAID 1, mirroring, duplicates data identically across 2 disks, reducing efficiency to 50%. RAID 5, striping with distributed parity, requires a minimum of 3 drives and can survive a single disk failure. Its capacity is calculated as total drives minus 1, multiplied by drive capacity. RAID 10, striped mirrors, requires at least 4 drives, combining striping speed with mirroring redundancy. 3.4 motherboards, CPUs, and add-on cards. The motherboard serves as the central communication backbone for the entire system. Form factor footprints. Standard ATX measures 12 by 9.6 inches. Micro ATX reduces dimensions to 9.6 by 9.6 inches while maintaining layout compatibility with ATX enclosures. Mini IDX measures 6.7 by 6.7 inches, designed for single expansion, low power systems. PCIe expansion bus, Peripheral Component Interconnect Express, PCIe, uses serial point-to-point links called lanes, such as X1, X4, X8, or X16, to route data. CPU socket styles. Intel platforms use LGA, land grid array, sockets, where the structural connection pins are located inside the motherboard socket cavity. Legacy AMD desktop systems use PGA, pin grid array, layouts, where the physical connection pins project from the underside of the processor chip. Firmware security layers. Modern Unified Extensible Firmware Interface, UEFI, replaced the legacy BIOS, adding mouse-driven GUIs, support for boot drives over 2.2 terabytes using the GPT partitioning schema, and secure boot verification to block and sign rootkits during startup. TPM, Trusted Platform Module. Chips securely generate and store cryptographic keys to manage full disk security solutions like Windows BitLocker. 3.5 power supplies, PSU. Power supplies convert high-voltage AC input from utility lines into stable, low-voltage DC current. Input selection. Manual dual-voltage switches toggle between 115V, standard in North America, and 230V, standard in Europe. High-end power supplies use auto-switching circuitry. DC rail distributions. Output line supply plus 3.3V, plus 5V, powering integrated motherboard logic chips, and plus 12V, delivering power to high-draw components like cooling fans, mechanical drives, and PCIe graphics expansion cards. Connector configurations. Power distribution uses standard connector types. A 24-pin main motherboard connector, a 4/8-pin auxiliary CPU power connector, 6/8-pin PCIe graphics cards leads, 15-pin flat L-shaped SATA power links, and legacy 4-pin Molex connectors. 3.6 multi-function printers. Printers use distinct imaging technologies that require specific maintenance routines. Laser printers. High volume, high-speed document systems utilizing fine carbon plastic toner powder. You must memorize the 7 steps of the electrophotographic imaging cycle in exact sequence. 1. Processing. The internal printer controller compiles the document and creates a rasterized image of the page in its local memory. 2. Charging. The primary corona wire or charge roller applies a uniform high negative electrical charge, approximately -600V, across the photosensitive drum surface. 3. Exposing. An internal laser beam draws the page image across the drum, discharging exposed areas to a weaker negative charge, approximately -100V, to form an electrostatic latent image. 4. Developing. Roller assemblies coat the drum with negatively charged toner particles, which adhere to the less negative, laser-exposed areas of the drum. 5. Transferring. A high positive charge is applied to the paper as it enters the assembly, drawing the negatively charged toner particles away from the drum and onto the page. 6. Fusing. The paper passes through high-temperature pressure rollers that melt and fuse the toner permanently into the paper fibers. 7. Cleaning. A rubber wiper blade scrapes residual toner off the drum, and an erase lamp clears any remaining latent electrical charges from its surface. Inkjet printers. Use moving carriage systems with piezoelectric or thermal elements to spray tiny ink droplets through precision nozzles. They offer high color fidelity, but are prone to printhead clogs if left unused. Thermal printers. Use heated printheads to darken specific points on chemically treated, heat-sensitive paper. They require no ink or toner and are common in retail point-of-sale receipt terminals. Prints can fade if exposed to heat or light. Impact. Matrix printers. Use a matrix of physical pins to strike an inked fabric ribbon against paper. They are noisy and low resolution, but are required to print through multi-part carbon copy forms. 3D printers melt plastic filament materials, such as PLA or ABS, through a heated extrusion nozzle, building physical models layer by layer based on digital slicing files. Domain 3.0 mini summary. Cat6 handles 10 gigabits per second up to 55 M. Cat6A supports 10 gigabits per second up to 100 M. Platinum-rated jackets are mandatory in drop ceilings. ECC memory checks and fixes data errors automatically. It is used only in server and workstation environments. RAID 0 offers speed with no safety. RAID 1 mirrors data. RAID 5 handles single-drive failures using parity blocks across a minimum of 3 disks. The laser printing cycle follows an exact sequence: processing, charging, exposing, developing, transferring, fusing, cleaning. Before we continue to Domain 4, let's do a review of what we just covered in Domain 3 with a short quiz. Question 1. Which connector type is most commonly used for a VGA analog video connection? A. HDMI. B. DisplayPort. C. VGA D-sub. D. USB-C. Correct answer: C. VGA D-sub. Explanation: VGA uses a D-sub connector shape for analog video. Question 2. What is the primary purpose of RAM in a computer? A. Permanent storage for files. B. Temporary workspace for running programs. C. Converting power from AC to DC. D. Cooling the CPU. Correct answer: B. Temporary workspace for running programs. Explanation: RAM temporarily holds data/program instructions while tasks are running. Question 3. Which storage option uses flash memory and typically has faster access than a traditional HDD? A. SSD. B. HDD. C. Magnetic tape. D. Optical disc only. Correct answer: A. SSD. Explanation: SSDs are flash-based and generally faster than HDDs. Question 4. RAID 1 is most associated with what benefit? A. Better read/write speed via striping. B. Data redundancy via mirroring. C. Larger usable capacity with no redundancy. D. Eliminating the need for backups. Correct answer: B. Data redundancy via mirroring. Explanation: RAID 1 mirrors the same data across 2 or more drives. Question 5. Which component's main job is to execute instructions, the brain of the computer? A. CPU. B. Power supply unit, PSU. C. Motherboard chipset only. D. RAM controller card. Correct answer: A. CPU. Explanation: the CPU executes instructions and performs computation. Domain 4 next, we'll cover